All right. That's good. There we go. I'm just going to put this video together to run through some of the review problems for the 6-4-6-8 quiz. If you want to watch the whole thing, great. If you want to kind of just go from chunk to chunk, I will try to put kind of like whatever. In the comments, I'll put at what point we get to each of these 6 categories. So if there's a certain one that you want to look at and want to fast forward to that, fantastic. This also might be the last video that I put together, depending upon what your opinion is of the flipped classroom. So we'll see how this goes. We covered 5 sections in this little like unit. These first 2 topics are from 6.4, and then everything else is from the following sections. So 6.5, 6.6, 6.8 is the graphing radical, and then 6.7. And I think I might have it in reverse order. I think I might have 6.7 and then 6.8, but again, I'll put the timestamps in the comments so you can kind of like fast forward through some of those things. I'm going to go ahead and just jump in right away at 6.4. This was basically switching between radical form and exponential form using fractional exponents, and then simplifying if we can. So if we take a look at this first problem, the instructions say write each expression into radical form and then simplify when possible. Okay, so I see that exponent of 3/4, and I know I'm going to have to use a radical. I know that the 4 is going to be my index, and here's where you need to be careful that this exponent is only applying to the variable. That is not applying to the 81. Otherwise, you would see parentheses around it. Something like this is what you would see. But since I don't see parentheses, that exponent is only applying to the variable x. So that means x to the third is going to go underneath the radical. 81 does not have an exponent, so I'm just going to put 81 up front. Put a multiplication sign if you want to. There's nothing I can simplify with this because I'm not raising 81 to a power. And so this would be then my final answer. Fully simplified, nailed it. Okay. Next is if I have 16 to the 1/3 times 4 to the 1/3. We learned with our exponent rules that you could add those powers together, but they have to be the same base. So if they're both 4 as their base number, then we could just add the exponents. As it stands, they're not the same base number, but we know that I can write this as the third root of 16 times the third root of 4. And since they are both cube roots, I can then multiply the radicands, or I can multiply 16 and 4 together to get the third root of 64. So that would be in radical form. Of course, I could always try to type in the third root of 64 to see if it simplifies, and it does to just 4. So radical forms on the left, simplified version on the right. Okay. So that is the first little chunk that we had from 6.4. And then we also had, like, again, just some bigger expressions that have exponents. This is kind of what I was talking about on the last slide. Here, my exponent is 1/3, but it is applying to everything in the parentheses. So I'm going to split this up as -8 to the 1/3 and y to the 9th to the 1/3 power. Okay, so I've got 2 separate things going on here. On the left, that -8 to the 1/3 power, I could rewrite as a radical, or I can just type it in the calculator. If you are going to choose to type this in the calculator, please remember that you need to put parentheses around that 1/3 power. So just to kind of show what that looks like, if I were to type this into my, I would need to put -8 in parentheses. That's every calculator. Technically, and we went through this in class, some of your calculators, you don't need the parentheses, but it's always safe to just throw parentheses around it and do 1 divided by 3. Okay, and I get a new value of -2. So I'm going to come back here. So my front value is going to be -2. And then since I have a power for this variable, since I have an exponent raised to another exponent, I'm going to multiply those together. 9 times 1/3 or 9 divided by 3 is the same thing. So it'd be y to the 3rd power. Bam. Simplified. Done. Okay. And then here, if I just have multiple variables like x to the 1/6, holy smokes, and y to the 1/3, those are both being raised to the negative 18th power. This is where if you wanted to, you got some options here. One way you could do this problem, oh boy, is to put this over 1, right? Because we know anything to a negative exponent, that's no good. So what I could do is take this new fraction, flip it on itself, and then rewrite it to the positive 18th power. So this would be 1 over x to the 1/6 times y to the 1/3, and all of this is raised to the 18th. If I do simplify this, then 1 to the 18th power, well, that's 1 to any power is just going to be 1. I have power to a power, so 18 divided by 6, or 1/6 times 18 is 3, so it'd be x to the 3rd, and then y to the 1/3 and the 18 again. 1/3 of 18 is 6, so it's y to the 6th power. Can't combine x and y, so there we go. Fully simplified. Okay. So those 4 problems, again, this is not a comprehensive review. This is just hitting on some of the big highlighted points that we had from each section. So that was 6.4. In 6.5, we now started to use what we know to combine with old algebra skills to actually solve these equations. So if I see something like this that has a radical in it, I need to first make sure this radical gets isolated. It should be by itself. So I need to get rid of the -2. Remember, there's no such thing as distributing a coefficient with a square root. So instead, I'm just going to divide by -2 on both sides. If I do that, I then have the square root of 2x plus 6 equals positive 7. Now that I have the square root isolated, I'm going to go ahead and square both sides. Square that, and we get 2x plus 6, right, because that undoes that, is equal to 49. At this point, I'm going to subtract 6, 2x is equal to 43, which is not a clean number, but that's 21.5. Or you could leave it 43 over 2. Okay. And remember, since this moment right here, when I squared both sides of the equation, so this step right here is kind of the big one. Since I didn't have x on both sides of the equation, I just had the variable on the left side but not the right side, I technically don't have to go back and check that answer. If you ask another math teacher, that's not technically right, but it's fine. We're going to leave it. Feel free to go back and check your work, right? If you got extra time, check your work. Why not? If your problem is not a radical, but it's instead a fractional power, remember, this is where I'm still going to isolate that piece of it first. So in this case, I'm going to divide by 3. X minus 7 to the 4/3 power equals 2. That's 256. Okay. Now, in order to get rid of the 4/3 power, I'm going to raise both sides to the 3/4. Okay, that's where we're going to use the reciprocal power. So I'm going to take the right side here and raise it to the 3/4. And when I do that same thing to this side, these reciprocal powers will cancel each other out, leaving me with just x minus 7. So I got x minus 7 is equal to, and then 256 to the 3/4. Remember, this is kind of that tricky situation. I can type this in the calculator, and you'll get, oh boy, 16. Yep. So you should get 64 in the calculator. Let's double check. 256, I'm more confident now that I've started typing it, to the 3/4 power is 64. But technically what we're doing here is we are taking the fourth root of 256, right, because it's the denominator of 4, which is equal to 4, and then we raise it to the third power, and that's how we got 64. Okay. Again, the 3 coming from the numerator. Because we fourth rooted both sides, that's the same rules as square rooting both sides. I need to use plus and minus here. So don't just put equals 64, but in this case, this is a plus and minus 64. This would be one of those things that if you don't know why that is, or you struggle to remember when to use it and when not to, you got to ask, okay? And so because I have two solutions here, both, right, I have the positive 64 and the negative 64, I'm going to split this up. X minus 7 equals positive 64, and x minus 7 equals negative 64. For both of these, I'm just going to add 7 to both sides. 64 plus 7 is 71. Negative 64 plus 7 is negative 57. Okay. So there came out to be two answers there. Again, if you have time on any sort of assessment and you have time to go back and plug in your 71 to check your work, you should be doing that. For this, I know there's no variable on the right side, so I don't need to go through and check it. That was the day 1 of 6.5. Day 2, solve the equation, check for extraneous solutions. Again, getting that square root by itself, I'm going to add 6 to both sides. This is where I know now, since I have the square root of a variable expression, and I have that same variable on the other side, the x plus 6 on the right, and the square root of 2x plus 15 on the left, I know I'm going to have to check my answers, plus the directions said check for extraneous solutions. Same first step, right? I'm going to take this and square this side, take that and square that side. Okay. Again, square root cancels square, and I just have 2x plus 15 over here. This is where please, please, please don't just put x squared plus 36. Okay. Someone's going to do it. Don't let that be you. If it happens, it happens, but do your best to not make that mistake. But remember, this is actually pretty close to the right answer. The only thing I need to do is get the middle term, and if you don't remember the trick, don't do the trick, just multiply it out. But the trick is I'm going to multiply my inside terms. So I'm going to multiply x with 6 and then double it. So x times 6 is 6x doubled makes 12x. So x plus 6 to the second power equals those three terms on the right side. Now my equation has x to the second power in it, which means I have to get one side equal to 0. Okay, so I'm going to move the 2x from the left to the right, and I'm going to subtract the 15 from the left and also from the right. By doing so, those cancel, and I get 0 equals, you get x squared plus 10x plus 21. Okay, and now I want a factor. So I need to find factors of 21 that add up to 10. There's not a whole lot of numbers that multiply to 21, and thankfully 7 and 3 work, right? That fits the bill here. So I have 0 equals x plus 7 times x plus 3. And then I want to figure out, okay, and the reason we factor is, all right, what x value is going to make that parentheses or that factor equal to 0? Well, that's going to be negative 7. And what x value could I plug in and make the second set of parentheses equal to 0? Well, that's negative 3. So right now, okay, there's all that work. 1, both, none of them. I don't know how many of those solutions work because I have to plug it in to check. Okay, I am going to go back to the very original equation and check this. So I'm first going to start with x equals negative 7. I'm going to do the square root of 2 times negative 7. Okay, I'm going to make the jump here and just call it negative 14 plus 15 minus 6. Does that equal negative 7? That's the square root of 1, which is 1. If I do 1, take away 6, That does not equal -7. That is -5. So this is extraneous. You do not have NA. You do not have to remember how to spell extraneous. Just cross out that word, or cross out that solution. X equals -3 is probably going to work, but we still want to check it real quick. So this is the square root. Again, if it's 2x, 2 times -3 would be -6 plus 15. And then if I take away 6, do I get that same x value back? Oh boy. Which is -3. Okay. So -6, screen's all over the place. -6 plus 15 is 9. The square root of 9 is 3. And sure enough, if I do 3 take away 6, I will get -3, which means that this is my only solution. Okay. And I know different teachers teach it differently. If you have your answer looking just like this, like if this is what I see on your test, you're going to be in good shape. Okay. Show me that you got both numbers. Show me that you checked both numbers, and then show me that just put a line through the one that is extraneous, meaning it doesn't work. Again, extraneous means it looks like it works, but when we plug it back in, it didn't. Okay. So yeah, that's kind of 6.5 in a nutshell. The next section we did was 6.6, which was the function operation, so adding, subtracting, multiplying, dividing, as well as that new composition of functions. And we also reintroduced the discussion of domain here. So here I have two functions, f of x, oh boy, f of x equals x minus 4, and g of x equals x squared minus 16. The first thing I'm asked to do is subtract those functions. So what I'm going to do is take the g function, which is x squared minus 16, minus the f function, which is x minus 4. Okay. I technically don't need the parentheses around the first function because there's nothing out here to distribute. So I can just drop the parentheses off here. Even though there's not a number in this second set of parentheses, there is a negative sign, so I do have to distribute that. So if I do -1 basically times x, that's minus x, and -1 times -4 is positive 4. From here, I'm just going to combine like terms if I can. I have x squared and no other x to the seconds. Then I have minus x, so it goes next. -16 and positive 4 can combine to be -12. You do not have to worry about factoring this right now. Leave it for chapter 8. I've done you've done what I've asked you to do, which is to combine the functions. The last thing is we need to find the domain. Two big questions. Is it a fraction? Because I can't divide by 0. And is it a square root? Because I can't square root a negative. Neither one of these are true for this function, so the domain is going to be all real numbers. Okay. If it's a division problem, and some of you were asking about how do I divide, for this chapter, just set it up as a fraction and then look at the domain. So g of x was x squared minus 16, so that's going to be my numerator. And then the denominator is x minus 4. You actually can factor the top and do some simplification, but again, we're gonna worry about it in chapter 8. Let's talk about the domain, and then I'll simplify just for practice to see. Again, it is a fraction, so I can't have the denominator equal to 0. And I see that if I were to replace that variable with the number 4, so this said 4 minus 4, right? That would be bad because I'd be dividing by 0. So that is the number that is not in my domain. So for the domain for this, I would say x cannot be positive 4. Any other number works, cannot be positive 4. Okay. Unnecessary 30 seconds, but just real quick. You could factor this. You're basically trying to figure out what two numbers multiply -16, but add to 0 because the b term, the middle x term is gone. So the top would actually factor into x minus 4 times x plus 4. That's what x squared minus 16 would factor into. And then I have my denominator of x minus 4. Okay. Technically, these can simplify. The x minus 4 can cancel the x minus 4. And this would be your final answer. Again, unnecessary 30 seconds. If you skipped it, great. You never saw it. Congratulations. So that was 6.6, subtracting and dividing, and then the last thing we did in 6.6, and this was the new part, was the composite functions, or the compositional functions. So if we have something like h of g of -1, okay, this is telling me to, again, we're going to kind of work backwards. So I'm going to take -1 and plug that into the g function. Okay, I see the g function is 5x minus 2. So 5 times -1 minus 2. If I keep evaluating this, that is -5. 5 times -1. Take away 2, so g of -1 is -7. Now this is my answer. I'm going to take that number and plug it into h. Okay, so we take the answer for the one, for the right-hand function, and we're going to plug that answer in for the input for the h function in this case. So I'm going to do h of -7, which is x squared plus 1. H of -7. -7 squared is 49. 49 plus 1 is 50. So h of -7 is 50. So what I would do is go up to the very top here. 50 was my final answer. So I could say h of g of -1 is equal to 50. Okay. Remember, this is the other way that you'll see it. Sometimes it's an open circle like this. Sometimes it is just the double parentheses like that. It means the same thing. G of h of G of h of 2. So I'm going to take 2 and plug it into the h function. H of 2 equals 2 squared plus 1. 2 squared is 4. Add 1 is 5. Okay. Again, here's my output that is going to then go into the g function. So g of 5 is, what was the g function? 5x minus 2. So 5 times x minus 2. 5 times 5 is 25. And if I take away 2 from that, I will get 23. Okay. Again, final result is 23. So I would come up here and say g of h of 2 equals 23. Okay. So composition of functions, hooray, huzzah. So adding, subtracting, again, I didn't do adding and multiplying. I think those are the ones that that we interact with the most and we do the most. So adding, subtracting, multiplying, dividing, and then this composition of functions is what 6.6 was all about. We then jump to 6.8. So I'm going to go to 6.8 first, actually. Graph the function, find its domain and range. So this is a square root function right at its core. I see the square root here. There are some other translations going on, or some other transformations going on. I'm going to start with my just basic square root of x. I know that the easiest numbers to square root are 0, 1, and 4. And those are, the results are 0, 1, and 2. Okay. I'm not going to graph those coordinates. One thing that we didn't talk about, and if you're watching this, great, I'll try to remember to bring it up, is what are the domain and range of this thing? So the domain is what x values can I plug in. Again, right now I'm just looking at this. What x values can I plug into that? Well, x has to be greater than or equal to 0. And the range is what answers will I get out. As you can see, 0 is the smallest number. Like if I were to keep this table going, the y values would only keep increasing from 0, 1, and 2. And it's not going to go negative because I can't get a negative as a square root when I'm evaluating. So I would say the range is y is greater than or equal to 0 also. Okay. Then the next thing we did was we brought in the stretch or compression. So 3 times the square root of x. Again, that is a vertical stretch. So that means I'm taking my y coordinates and I'm multiplying them by 3. Okay. So my 0, 1, and 2 that I had here, I'm going to triple those and they will become 0, 3, and 6. Okay. What's interesting about that is even when I triple, so the x values were unchanged completely, right? I didn't do anything with the x values. So the domain here is x is still greater than or equal to 0. Even though I tripled the y values, the smallest y value I have is still 0. So my range would be y is greater than or equal to 0. Okay. And then finally, the last step we need to do to get my full function, or the function that I'm looking for right here, is to take care of that -6, which we know moves the function to the right by 6, right 6. If I need to move a function to the right 6 units, that's going to, again, shifting to the right on a graph is increasing your x coordinates. So what I'm going to do for this last table is I'm going to take these x values that I had of 0, 1, and 2, and I'm going to add 6 to all of them. Okay, so my final XY chart, I don't know why I'm doing this. I'm just going to make it smaller. Of course, I took the box with it. So last thing we're going to do here is take the x values and add 6 to them. Oh boy. X plus 6. So my x and y are 6, 7, and 8 now instead of 0, 1, and 2. We're going to keep the same y coordinate 0, 3, and 6. Since I added 6 to all the x values, 6 is now the smallest number in my domain. Okay, so I'm essentially just adding 6 to the previous domain as well. Just like here, I could say that I multiplied 3 to the range. The range was started at 0, so that's why it stayed 0. So x is greater than or equal to 6. This last step right here, I didn't mess with the y coordinates at all. So my range is still going to be y is greater than or equal to 0. Okay, so I got 6, 0. Oh boy. 6, 0, 7, 3, and 8, 6. 8, 6. 0, 1, 2. What did I do wrong? 7, 3, 8, 6. Oh, shoot. Okay. Sorry. And you're probably yelling at your screen by now. Stupid. So back here, I'm not going to edit this out because this is real life, and this is sometimes what you got to do, right? Good test taking tip, just for a brief second. I looked at this. This does not look anything like what we've graphed. No square root function looks yard sale. No, nothing that we've done looks like that. Okay, we know it has that sort of like gentle arcing motion, or it flattens out. So like, if your graph looks ridiculous, something went wrong. So go back and see what you can do to change it. And I did the dumbest thing. 0, 1, and 4 magically became 0, 1, and 2. Now how's that going to work? It doesn't. So this needs to change to 4. And when I add 6 to that number, this should then become 10. Silly little mistake. Changed my whole graph. Shook me a little bit. You saw it live on camera. I know all of YouTube, all these people watching, will see as well. 7, 3, right there, and 10, 6. Okay, that looks a lot better. I now have a square root function. Oh, okay. That took longer than I figured it was going to. So let's look at one more example real quick. Now one where it's got the negative out in front. Again, going to start with just y equals the square root of x. 0, 1, and 4. 0, 1, and 2. I then am going to introduce the negative sign, which means the y values I'm going to multiply by -1. Remember, you can always put the 1 in there if you want to. So x, y, I've got 0, 1, and 4 still. If I multiply my y coordinates by -1, those just become negative, so -1 and -2. I know this last thing, and I'm going to do both of these in one step. This is going to go to the left 4 units. This is going to go up 5 units. So that means to go left 4 units, my x coordinates are going to, I'm going to take away 4 from the x coordinates. And then to go up 5, that means the y coordinates are increasing by 5. So I'm just going to do that to each one of the values here. So this is my full function, y equals negative square root of x plus 4 plus 5. Okay. Taking away 4 from each of those, -4, -3, and 0. I think that's right. Then this should be 5, 4, and 3. Okay. So those are my 3 coordinates, -4, 5, -3, 4, and 0, 3. 1, 2, 3. So I have kind of this downward curving square root function. Of course, didn't do domain and range this whole time. But again, if you start with the domain is x is greater than or equal to 0, and so is the range. Okay. Well, if I multiply it by -1, now here is what happens. Since I'm multiplying by -1, if I multiply 0 by -1, nothing happens. It's still 0, but it does reverse the inequality. So now my range is going to switch to range is y is less than or equal to 0. Okay. Again, this change is happening because I multiplied by a -1. The x values for this first step remained unchanged, so that would be x is greater than or equal to 0. And then, of course, if I subtract 4 from the x's and add 5 to the y's, I'm just going to do the exact same thing to my domain and my range. So this is x is greater than or equal to -4. Again, not changing the inequality because I didn't multiply. I'm just subtracting and adding. The range here then is y is, what do we do? Added 5, so less than or equal to 5. And you can see, like, if domain and range is confusing to you, look at the graph, okay? Where did the graph start? Or where did this square root function start? Well, it started right here at this coordinate, and that coordinate is -4, 5. Okay? Well, from the x coordinate of -4, there's my x coordinate -4 right there. Where did the graph go? It went to the right. Moving to the right on the x-axis means that x is going to be greater than -4. Okay. By the same token, this thing starts at a y value of 5 and goes where? It goes down. It's going down, which means it's decreasing, which means the y value is going to be less than or equal to 5. Just another way to look at it. I don't know. Again, like, we're going to use domain and range a ton throughout the rest of the try. So if you can just get in the hang of it and feel good with it, awesome. 6.8. Okay. I was going to run a timer, so I knew where I was at, but forgot to start it. I'm sure I could look, but this is already ridiculous enough. Okay, last thing was 6.7, which is our most recent section. Graph the function and its inverse, including the domain and range of each. Okay, well, let's start with domain and range of this thing. Hopefully I recognize that that's a parabola because it's got x squared in it, and that's the largest exponent. So my domain here is going to be all real numbers. Anytime I have a parabola, that's my domain. Depending upon how much you remember from last try, since the a value or the coefficient of x squared is positive, that's going to be a parabola that opens up. And since I have a -8 here, okay, that means it's going to slide down 8. And the range is going to be y is greater than or equal to -8. But I do want to take a look and see how that happens real quick. Okay. If you don't know what the graph of 2x squared minus 8 looks like, totally fine. Just pick a couple random numbers. Okay. I'm going to pick I'm going to pick -1, 0, and +1. I could just plug each of those numbers in for x, right? I could just plug in -1 and then plug in 0 and plug in 1. What the values you end up getting will be -6, -8, and -6. So if I look, if I plot those points, okay, -1, -6, -1, -6, 0, -8, and 1, -6, I can see how this is going to be a parabola. So I know it's going to look something like that. Okay. Both sides are going to continue going up. So that's great. That's all that. Now I want the inverse. And if you remember from the inverse, like to graph it, it should be pretty simple. All I have to do to graph the inverse is switch x and y around. Okay. So for the inverse, I know that the x values are going to be -6, -8, and -6 again. And then this will be -1, 0, and +1. If I look here, -6, -1, -8, 0, and -6, +1. Okay, and I can see I get this sort of sideways looking parabola. And if you're graphically, you should be able to tell something is an inverse very quickly by like, is it flipped across this 45-degree line? Okay. Do those things look like mirror reflections of each other over the 45-degree line? And if you kind of tilt your head a little bit to the side, you can see that they kind of line up. And if you were to fold the paper on the pink line, then they would line up. All right. But what is the equation of that inverse? This is where I'm going to take the original, that 2x squared minus 8, and I'm going to write it as y equals 2x squared minus 8. I'm then going to swap the x and the y around. So I'm going to reverse the order of those. So 2y squared minus 8. I'm then just going to solve for y, or get y back by itself. So I add 8 to both. Oh boy. I'm going to add 8 to both sides. So I have x plus 8 equals 2y squared. Divide this by 2. Then I have x plus 8 over 2 equals y squared. My final step to get y completely by itself is to square root both sides. And remember, when we introduce a square root in an equation or in a function, I need to use plus and minus. Okay. Remember, the inverse is also written as f -1 of x. Okay. So here is, let's kind of go through this real quick. Here's the original function, graphed right here. Here's its domain and range. Okay. Then we switched the coordinates around. Right. We switched the coordinates from the table above, graphed it over here, confirmed that it looks like a mirror flip. And then the most mathy part was we had to find the equation for the inverse by switching x and y. The last thing that we haven't done is we need to talk domain and range. But remember, if you know the original, the domain and range for the inverse should be very easy. Domain's x, range is y. Here, the domain of the original, right? The domain was all real numbers. So that is now going to be the range of the inverse. Those just switch places, just like x and y switched, swapped, whatever. So the range is going to be all real numbers now. And the range was y is greater than or equal to -8. That then is going to be the domain. X is greater than or equal to -8. And you can kind of see that from the graph, right? If we look at this function, it's starting at -8 and going to the right. And then the range, it's going to hit every y coordinate. This will hit all the positives. This will hit all the negatives. I did misspeak a little bit. Remember, a function graphically means that it can pass the vertical line test. Okay, this parabola passes the vertical line test, so it is a function. The inverse is not a function because it doesn't pass the vertical line test. That this question didn't ask it, but this would be a function, and this would be not a function. Okay. There's a lot on that slide, a lot that we did, but again, just trying to explain what we're doing. We're going to run through one more, and then we'll wrap this up. 9:05, just about bedtime. So graph the function and its inverse. Again, this is a square root function, so we should feel pretty comfortable starting with 0, 0, 1, 1, and 4, 2. Right, that's going to move my function to the right 3 units. So that means I'm going to add 3 to the x values. So my x and y will now be, instead of 0, 1, and 4, will be 3, 4, and 7. Y coordinates are going to stay the same. Again, domain of my starting is x is greater than or equal to 0, and the same for the range. Okay. Since I added 3 to the x's, I added 3 to the x values. That means I'm going to add 3 to the domain value. So here the domain is going to be x is greater than or equal to 3, and the range is going to stay the same as y is greater than or equal to 0. Let's go ahead and graph this thing quick. 3, 0, 4, 1, and 7, 2. Boop. There's my graph right there. Okay. Again, now we're trying to figure out what the inverse looks like. Again, graphically, I should expect something that's flipped over this y equals x line. Okay. So it's going to be over in this area somewhere, I'm guessing. To find that inverse, again, for the table, let's just reverse the values. So x, y is going to be 0, 3, 1, 4, and 2, 7. So 0, 3, 1, 4, and 2, 7. Sure enough, I get that same sort of mirrored look in the graph. Awesome. The last thing we got to do is define what the equation of that inverse is. I say last thing, we still haven't done domain and range, but that'll go pretty quick. So this was y equals the square root of x minus 3. Again, swap x and y, square root of y minus 3. I'm going to then square both sides to get rid of the square root. That's my first order of business. X squared equals y minus 3. Then I'm going to add 3 to both sides, add 3, and I get x squared plus 3 equals y, which is again referred to as, is this f? No, I use g, which is also referred to as g inverse of x. Okay, so here's the equation for the inverse. Holy smokes. Quiet down, you. Okay. What do we got? Oh, domain and range. So if you're thinking to yourself, and you might not be, like, hey, I thought this was, I don't know why, that's my voice. Hey, I thought this was going to be a parabola. And if you look at the graph, that's not a full parabola. That's half of one. But the reasoning is because I need to take the domain and range of the original function, and again, I'm only flipping it. I'm reversing the values for domain and range, the actual numbers. So the domain of this function is going to be x is greater than or equal to 0. And again, this 0 comes from that 0. Like those two zeros are linked. They just switch spots. Actually, it also like includes the inequality too. And then for the range, I have y is greater than or equal to 3 instead of what was before x is greater than or equal to 3. Okay, so that came from that. So because, and this is what's weird, is because the domain is only set to be x is greater than or equal to 0, even though this isn't this isn't a fraction, it doesn't have a square root, but I came from a function that was a square root. What ends up happening is you get something that you would expect to be a parabola, but in order for this to be graphically like a reflection, right, in order for it to be a true reflection, it has to match up perfectly. So we only get half of this parabola. So the other like ghost half of the parabola does not exist anymore. Oh boy. Okay. Again, not everything that's on the test, not everything we've covered, but a very good highlight, and it probably feels exhaustive because it's pretty exhausting. There's the list of homeworks that are due. If you're watching this, you're probably already familiar with what is due. These 6 are being graded. The review worksheet is optional. It is not being graded, but it is a great resource for you to use. This may be the last time I make a video. So if it is, sorry, you're going to see less of my webcammed face. And if it's not the last time I make a video, then I will see you next time. 46 minutes? Oh boy.